Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in this particular video, I'll be teaching the second chapter of 9th standard science subject, that is matter around us pure? So in my previous videos, I was actually explaining the first chapter of 9th standard science subject, where I have explained matter in our surroundings. How matter is composed with particles, what are all the characteristics of particles, how the characteristics of particles vary, all these things we have actually discussed in our previous videos. So in this particular video, we'll be discussing about how matter around us are pure or impure. In this chapter, we'll be learning mixtures, types of mixtures, solutions, types of solutions, and all those things. We'll also be learning about elements, compounds, different chemical changes, physical changes of a matter. All these things we'll be covering in this particular chapter. So from a non-science perspective, if you actually see the word pure, what do you mean by pure? So anything which doesn't contain unwanted things, then that particular substance you actually call it as a pure substance. So for example, if you bring a certain food product from a shop, so that particular food product contains certain elements or substance in it. So in this particular substance, there will be various chemical elements present. There will be various chemical substance present. So, but still the company will tell you that this particular food substance is pure, because pure from a non-science perspective tells that any substance which doesn't have any unwanted things in it, then that particular substance is known as pure. But from a science perspective, any kind of chemical substance which contains same chemical combination throughout the substance, that particular substance can be known as pure substance. For example, if we take water, a pure water, so in this particular water, the composition of water is H2O, and this particular H2O combination will be there throughout the water without any other chemicals present. So this particular water can be known as pure according to science. Even if you take another example of sugar crystal or a salt or any kind of substance, that particular substance will not contain any other chemical other than the required chemical elements which are necessary for that particular compound to be formed. So let's say this particular crystal is NaCl. So this particular entire crystal, everywhere it contains NaCl as its chemical compound. So that means it doesn't contain any other chemical compound other than NaCl. So that particular NaCl crystal will be known as pure, because that particular NaCl crystal doesn't contain any other chemical elements or any other chemical compounds which are present in between this NaCl. Now, if you mix this particular NaCl into this water, then you cannot tell this particular water as a pure water, because this particular water will be containing H2O plus NaCl. That means two kinds of chemical compounds are present in one single substance. That is, if you go on seeing the chemical substance of this entire water, there will be both H2O and NaCl. That means there is a form of mixture present in this particular substance. So at that particular time, this substance will not be a pure substance. Now water is not pure because water is now mixed with NaCl. So any substance which has same chemical substance throughout the boundaries of that particular substance, that particular substance will be known as pure in science. So any two kinds of pure substance come together and mix together, then that particular substance is known as mixtures. Those particular substance will never be pure, but that particular substance is made of pure substances. Let's say water and NaCl. So NaCl, if you are mixing in water, so let's say this is water which contains H2O in it. Now you are putting NaCl, that is salt crystals, into this particular H2O. So now H2O is one particular pure substance and NaCl is another kind of pure substance. When two pure substances you are actually mixing with each other, then that particular substance, that is water plus NaCl, will be known as mixture. That means this particular mixture contains different pure substances. One or more than one substance are mixed together. So that particular pure substances which are mixed together, one or more than one pure substances are mixed together, then that particular total substance will be known as mixture. In this mixture, you have two types. One is homogeneous mixture and the other is heterogeneous mixture. What happens in homogeneous mixture is that when two different substances of different chemical nature come together, at that particular time, there will be a chemical interaction between one substance and the other substance. That is one pure substance and the other pure substance. For example, if you are mixing NaCl in H2O, at this particular time, this particular NaCl will be split into Na plus ions and Cl minus ions, and these particular ions are trapped in between H2O molecules. That means this particular NaCl crystal is dissolved in the water, and this particular NaCl will be there throughout the solution. That means throughout the water, wherever the water boundaries are there, so throughout that particular water solution, NaCl will be mixed. So this kind of mixtures are known as homogeneous mixtures. So the main point in this particular homogeneous mixture is that there will be uniform distribution of components throughout the solution. There will be uniform composition of a particular substance in another substance. So here if you are taking H2O as one particular substance and NaCl as another particular substance, when you mix this NaCl into H2O, that is NaCl into water, at that particular time this NaCl will have uniform composition throughout the water. That means if you are taking 1 liter of water, every part of that particular water will be covered with NaCl. That means NaCl is dissolved throughout that particular 1 liter water. It is not confined to one particular position. So that's why a single drop from that particular 1 liter water, from wherever you pick one particular drop from that water, that will taste salt. That means this particular NaCl or the salt crystals have dissolved in the water and are uniformly distributed throughout the water. So this particular uniform distribution and having uniform composition throughout the another substance is known as homogeneous mixture. So now you are forming mixture between H2O and NaCl. These two are pure substances individually, but when they come together they form mixture and they form a uniform composition throughout them. That means this particular NaCl crystals are forming uniform composition throughout the water. Even another example for homogeneous mixture is that if you mix sugar in water, then also this particular sugar crystals will dissolve completely in the water. That means this particular sugar crystals will also have uniform composition throughout the water. So that's why H2O and NaCl or H2O and sugar or H2O, NaCl and sugar together, when they are put, they form a mixture, and this kind of mixture which has uniform composition throughout the solution, that particular mixtures are known as homogeneous mixtures. Coming to heterogeneous mixture, what happens in heterogeneous mixture is that there will be non-uniform composition of one particular substance in another particular pure substance. So now let's take the same example of water, but in this water, if you put some sand particles, let's say you have some sand particles, and if you are putting that sand particles into the water, now if you look at this particular position of water, there will be no sand particles. If you look at this particular position of water, there will be no sand particles, but only at this particular position of water sand particles are there. That means uniformly this particular sand particles are not distributed throughout the water. This particular non-uniform distribution of a particular pure substance in another pure substance is known as heterogeneous mixture. But in case of NaCl, like if you go for homogeneous mixture, in this if you put salt crystal in water, so even at this particular position water will be salty, at this particular position water will be salty, even at this particular position water will be salty, because the salt which you are putting in this particular water is completely dissolved in the water and it has covered all the portions of water. That means uniform mixture of salt is taking place inside this particular water. That means this particular water will have uniform composition of salt throughout the solution. So that's why this particular mixture is known as homogeneous mixture. But in heterogeneous mixture, if you are putting sand particles in this particular water, you will not find sand particles everywhere in this particular water. You will find sand particles only at certain position in this particular water. So that's why this kind of mixtures are known as heterogeneous mixture. Even if you are putting oil into water, let's say this is oil, this is water in a particular container, and let's say this is oil. So if you are putting oil in this particular water, oil will clearly form a layer on this particular water. That means oil will not mix properly with water. Even if you put water and oil in a bottle, you can clearly distinguish that oil will be floating on water. That shows oil is not mixing properly with water. So these kind of mixtures are also known as heterogeneous mixture. So example, you can give sand in water, and another example which you can give is oil in water. So oil in water never mix properly, never have a uniform composition, and even when you put sand particles into water, they will also not have uniform composition. Hence this kind of mixtures are known as heterogeneous mixtures. So you might be observing that when I was explaining homogeneous mixture, I was using one term called solution. So what do you mean by solution? So any kind of substance which are actually dissolving any kind of solid, liquid or gas in it completely, uniformly. That means uniform mixture is there with a liquid of any other solid, liquid or gas. That particular substance is actually known as solution. Now we are putting this particular salt into liquid, and this particular salt is forming a homogeneous mixture with this particular water. So now this can be known as salt solution. So what do you mean by solvent? What do you mean by solute? What do you mean by soluble? So whenever you take a particular substance, let's say water or any other substance, that particular substance which is actually taking the solids or liquids or gases into it will be known as solvent, and solute is that particular substance which will get dissolved in that particular liquid, which forms uniform mixture with that particular solvent, is known as solute. And what do you mean by soluble? Soluble means a particular pure substance which can be completely dissolved and it can form uniform composition throughout. That means it is forming a kind of homogeneous mixture with the liquid. Then that particular solute and solvent combination is known as solubility. So at that time you can tell the particular solid substance or a solute substance is soluble in that particular solvent. So here one particular solvent and the substance which is getting dissolved in that particular solvent is actually known as solute. So solvent means a component which dissolves another component in it. So one particular component dissolves another component. So the dissolving component is known as solute, but the component which will be responsible for dissolving a particular component will be known as solvent. So this particular component will be known as solvent, and the component which actually dissolves in this particular component is actually known as solute. So dissolved component or the component which gets dissolved in another component will be known as solute, and the component which will be responsible for dissolving this particular component will be known as solvent. So for example, if you are taking water in a particular container, and if you are taking sugar crystal or a salt crystal, then this particular water acts as solvent, because this particular water will dissolve the salt or sugar completely. So that's why water will be a solvent, and this particular sugar or salt which is getting mixed with this particular water, they get dissociated, they get dissolved in that particular water. Hence that particular sugar crystal or salt crystal will be known as solute. Together, when water and sugar or water and salt are there, this will form a solution. So whenever there is the combination of solvent and solute, so whenever there is combination of solvent and solute is taking place, then we call it as a solution. When you are putting salt or sugar into this particular water, at that particular time, all the salt particles, all the sugar particles will completely dissolve in this particular water. So this is actually known as soluble. That means completely this particular sugar and salt is getting dissolved throughout the water. That means it is forming a uniform composition throughout the water. So that shows this particular salt is soluble in water. Now if you are putting sand crystals into water, they do not get dissolved in this water, they'll just go and settle at the bottom surface of the water. So that shows this particular sand particles are insoluble in this particular water. That means sand particles are insoluble in water. So at that particular time, it is not a solution. So it cannot form a solution because this particular sand particles are not completely mixing or not homogeneously mixing with this particular water. So there is no uniform composition of sand particles inside water. Hence this is an heterogeneous mixture and it is not a solution. So now coming to the properties of solution. So the first property will be it should always be a homogeneous mixture. So always solution will be homogeneous mixture, because whenever you put a particular pure substance into another particular pure substance, that is one particular solute into a particular solvent, so at that particular time this particular solute should get dissolved completely and should form a uniform composition throughout that particular liquid substance. Then only there will be a uniform mixture, then only it can be known as homogeneous mixture and it can be known as solution. So you should remember, solution is always a homogeneous mixture. So when solution is formed, the particles which has got dissolved in that particular solvent or the solute which has got dissolved in that particular solvent will be having diameter. So I'll just write diameter of solution particles will be less than 1 nanometer. Whenever the diameter of this particular solution particles are less than 1 nanometer, you cannot see through your naked eyes. That's why when you dissolve salt into water, you cannot see the salt particles after that particular salt particles are dissolved in water. That means this particular salt particles have got mixed uniformly throughout the water and the diameter of that particular composition will be less than 1 nanometer. Hence you cannot see visible particles of salt inside water. But when you taste that particular water, you can feel the saltiness of that particular water. That means salt is there in water, but it is less than 1 nanometer. The diameter of that particular composition is less than 1 nanometer. Hence you cannot see the particles properly with your naked eyes. So this particular solution will always have a homogeneous mixture, and the diameter of these solution particles or the solute which has got mixed in that particular solvent will be less than 1 nanometer. Hence you cannot see that particular particles through your naked eyes. This is another property of solution. So coming to the third property in this particular solution, the solution particles are very, very tiny in size, which has diameter less than 1 nanometer. Hence they cannot scatter the light. That means light rays passing through this particular solution are not scattered. That means particles present in that particular solution are very, very small. These solution particles are very small. Light when passes through the solution, they cannot scatter the light at all. Hence light will be not visible when passed through a particular solution. So now you can take normal water and look at the light through that particular water. You can see some amount of light intensity is there. But now if you take salt solution or sugar solution and if you are seeing light from that particular sugar solution, the same light will appear to be less brighter, less intense, because the maximum amount of light is actually not scattered inside that particular solution. That means most of the light is getting absorbed in the solution. That means these solution particles are not scattering the light properly. Hence light is getting absorbed within the solution, and only little bit of light which has not got absorbed in this particular solution are traveling out of the solution, and only that particular light you are actually able to see. That shows the intensity of light has got reduced when it is passed through the solution. Or sometimes if you have a very thick solution, then light will not at all pass through that particular solution, because that particular solution contains too much of solute particles. Hence it will be very much highly concentrated solution. Because of high concentration of solute in that particular solution, light cannot pass through that particular solution, because the particles are very small in size. They cannot scatter the light. Because they cannot scatter the light, they don't make that light to pass through them. They absorb that particular light. Hence, the third property of solution is that light rays passing through the solution will not get scattered, making the path of light difficult to travel through that particular solution. So the third property of this solution is that light rays entering into the solution will not get scattered, hence the path of the light ray is not visible inside that particular solution. Coming to the next property of solution, solute cannot be separated from solvent through filtration. So that means if you are actually doing normal filtration, you cannot actually separate this particular solute from the solvent. So now if you are having salt solution, that means water mixed with salt. So if that particular salt solution is there, and if you are actually doing normal filtration process, you cannot remove that particular salt which is there in that particular water, because salt is uniformly mixed throughout the solution and the diameter of that particular particles will be less than 1 nanometer. You are using a cloth piece, or if you are using a Wattmann filter paper, so this particular cloth or a filter paper will have small pores in it which has diameter in few microns. Diameter of pores of a particular filter paper will be in few microns, and the diameter of solution particles, that means diameter of the solute which has completely dissolved in a particular solvent, so that particular solution will have particles having diameter less than 1 nanometer. So diameter will be in nanometer. So this particular diameter will be in nanometer. So what do you mean by nano and what do you mean by micro? So what do you mean by nano and what do you mean by micro? Micro is that particular term used for 10 power minus 6, and nano is the term which is used for 10 power minus 9. 10 power minus 6 is 0.000001. And when you say 10 power minus 9, 10 power minus 9 is 0.000080 zeros. After that we will have to put 1. So this is actually 10 power minus 6 and this is actually 10 power minus 9. So this is the diameter of the pores of that particular filter cloth, and this is the diameter of that particular particles. That means diameter of the particles are lesser than the diameter of the pores which are there in the filter cloth or filter paper. So that means this particular solute particles which are dissolved in solvent will easily pass through that particular cloth, because diameter of that particular solute particles is very less, that is in nanometer scale, and the diameter of that filter cloth pores are in the range of microns, that is in 10 power minus 6 meter. So this particular particles will easily pass through because the diameter of particles is less than that pore, so they can easily travel through the pore. If you are using filter paper to filter salt from water, then salt will not get filtered. Even the salt will come out with the water through the filter paper, and this particular diameter of solution particles will be having lesser diameter compared to the diameter of the pores of that particular filter paper. Hence they can easily pass through the filter paper. Hence solute cannot be separated from solvent of a solution using a filter paper. This is another property. So I have discussed 4 properties of solution. So these are all the properties which you should actually remember, and you can write these properties in your own words in your exams. So this is all there in this particular video. Remaining part of this particular chapters I will be uploading in further videos. So if you want to learn physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you should have to subscribe to my channel. Please do subscribe to my channel. Stay tuned with my channel. Thank you.